And in the construct the understanding, they have log 2x plus log 2x equals 2. So we're going to start by solving this one together. In fact, we're going to solve an even simpler one right before it. Log 3x equals 2. That's a very simple one to start off with. It's the most simplest log equation when you already have a single log and there's an x inside of the log. Remember what a log means. A log means 3 is the base, the answer over here is the exponent, and x is the answer to that question. So if you have log 3 of x equals 2, it's hard to think of it in this form, but if you use the definition of a logarithm and say, I know my base is 3, my exponent is 2, and my answer is x, then it's a little bit easier to see that x has to be 9. Okay? This is the key step. The key step is going from there to there. Now there's two different ways you can logically think about going to that step. The way that I did it here at first was using the definition of a logarithm. In the definition of a logarithm, we can change it to exponential form because we know the 3 is the base, then the 2 is the exponent, and x is the answer. We could have also, because it's an equation, and this is not something that people normally think of when doing an equation, but you have to do the same thing to one side as the other. So if I make these both the powers of a base 3, that equation would still be the same. 3 to the power log 3 of x would equal 3 to the power 2. So long as you do what you do to one side, you do the other. Because I mean, when we were solving equations, as soon as they had the same base, we said, well, I know that this equals this then because my bases are the same. And then if you think about inverses, you know that exponents and logarithms are inverses of each other. So if I have a base of 3 here, and in my exponent I have a log of base 3, these would cancel, and I would just get x equals 3 squared. Now most people find that kind of mathematical step, putting both things as an exponent with a base of 3, a little bit confusing. So most people choose the definition route when solving these. But what we're going to find with all of our log equations is we're going to follow the following steps. This is our goal. Our goal is to change it to exponential form because then we know how to solve for things. If we can change it to exponential form, we'll be fine. So a key step, as far as the steps for solving any logarithmic equation, will be, and I'll leave some space here because it's not the first step. In fact, it'll be our second step. But it's the most important step. And if you're trying to remember your steps, this is your goal. You want to change it to exponential form. Well, in order to change it to exponential form, we need to first have a single log. If we have a single log, then we'll be able to change it to exponential form. And then once we've changed it to exponential form, it will be easy to solve for x. You'll use all your skills from previous years for solving for x. And the last thing you have to do with all log equation is check for extraneous roots. In other words, the key thing for checking here is that we are not allowed to take the log of a negative number or 0. Because if you think about your log graph, what do all log graphs basically look like? Well, they have an asymptote here at x equals 0. And they either have that shape or flipped over the x-axis. But that is the basic log graph, and the log graph is only defined for positive x values, and it's not defined at 0 because you have an asymptote there. So what's going to happen is when we solve for x, sometimes we'll get multiple answers, but you have to plug those answers back into your original equation and see if any of those answers would ever cause you to take log of 0 or log of a negative number. You don't have to check that it actually works out perfectly, but you're just checking for positive and negative values. So that being said, with those steps, we can look back at this original equation. Do we have a single logarithm? Not yet. But our log laws say when I'm adding two logs together, that's the same as multiplying. So x times x becomes x squared. Now, I have a single logarithm. I'm going to use my definition of a log to change it to exponential form. My base is 2. My exponent is 2. And my answer is x squared. Again, this is the most important step. And I'm going to say it over and over again as the most important step because even though it's the most important step, it is the step that most students forget for whatever reason. You forget the most important step. At this point, you're going to get x squared equals 4. Solving for this, you know how to do. What are you going to get for x? Plus or minus 2. And now we have to check. When I plug in 2 into my original equation, it's a positive number here. That's fine. It's a positive number here. That's fine. But when I plug in negative 2, I'm taking log of a negative 2 already in the first one. I don't even have to check the second one, even though it's identical. I already know that negative 2 is not going to work, so x equals 2 is the only answer. On an exam in a question like this, I've seen sometimes they take off a half a mark if when you took the square root of both sides you just wrote 2. Sometimes they've taken off a full mark because they allotted a half a mark for you knowing that x squared equals 4 means plus or minus 2, and another half a mark for canceling out x equals 2. So you need to show somehow that you know that that negative isn't an answer. Sometimes they've been even particular without me putting something through that negative, just writing x equals 2 and circling it and not indicating that I know that the minus 2 is extraneous. They've taken a half a mark off there for communication. Oh, I went too far. Example 1. There we go. Pull it off to the side. So we know our steps. We want to change it to exponential form. That's our main goal. In order to do that, we need a single log. So here we have two logs, and there's a log plus a log. Our log laws say that you can put that together by multiplying. And then this would equal 4. Now we can change it to exponential form. The base is 3. The exponent is 4. Equal 9x squared. 81 divided by 9 will be 27 equals x squared. And so now you square root both sides. Plus or minus, and in this case, I'm going to write I'm going to write them separate instead of putting the plus or minus because it's going to be easier for me to cancel them out. So now when I check them with my original equation, I can't take the log of a negative number, so I know that this one is extraneous, and I only have one answer that works. Oh, I made a mistake. This is 81 divided by 9. Sorry, I did 81 divided by 3. 81 divided by 9, that should be 9, right? Makes these numbers a little bit nicer. 3 or negative 3, but this one we still have to put an x through. So the questions you can do for practice. 3, 4, and 9.